Welcome to The Explainer. Today, we're diving into a plant full of fascinating contradictions. It's a Southeast Asian leaf that's basically sparked the biggest psychoactive regulation fight in the US since synthetic cannabinoids. You might know it as a folk remedy, maybe a gas station staple, or even the subject of intense neuroscientific research. Yep, we're talking about kratom. To really understand the debate surrounding it, we've got to cut through all the noise and look directly at the science. So, here is our cognitive roadmap for today. We'll start with the kratom paradox, look at mitragynine and 7-OH, explore the concept of a biased opioid receptor, review real-world use and harms, and then unpack the massive 2026 regulatory split. Let's jump right into Section 1, the kratom paradox, 2 drugs in 1 plant. Now, the central mystery of this plant, scientifically known as Mitragynine speciosa, is how it behaves so completely differently depending on how much you take. It's wild. At lower doses, it acts very much like a stimulant. You get alertness, sociability, a mild burst of energy. But as you increase the dose, it totally shifts. It takes on an opioid-like profile, giving you pain relief, sedation, and euphoria. It's almost like a pharmacological Jekyll and Hyde. So it begs a pretty massive question, right? How does a single leaf produce such wildly contradictory effects? To figure that out, we have to zoom in, transitioning from the macro level of the whole leaf down to the micro level chemistry. Section 2, mitragynine and 7-OH, the 40+ alkaloids of Mitragynine speciosa. When we actually peel back the layers, we find that kratom isn't just one single molecule. The raw leaf actually contains over 40 different alkaloids, but 2 of them really dominate the conversation. Mitragynine makes up the vast bulk of the alkaloid content in the raw leaf, but pharmacologically speaking, it's actually a comparatively weak, atypical opioid. But then there's its shadow molecule, 7-hydroxymitragynine, or 7-OH for short. It's present in tiny, trace amounts, often well under 0.05% by dry weight. Yet 7-OH is where the real power lies. And here is the absolutely crucial point. 7-OH is roughly 10 times more potent at the mu-opioid receptor than baseline mitragynine. It's literally the key mediator of the leaf's pain-relieving effects. But here is the truly fascinating pharmacological twist. When you ingest the traditional leaf, your liver essentially acts like a rogue chemist. It metabolizes some of that abundant, weaker mitragynine and actively converts it right into the highly potent 7-OH. So much of kratom's opioid-like activity actually runs through this hepatic conversion inside your body. And this creates a built-in biological safety ceiling, because your body can only convert so much of it at one time. Section 3, a biased opioid receptor, the nano-level neuroscience. Now, building this out at the nano level inside your brain's receptors is where medicinal chemists get incredibly excited. Both mitragynine and 7-OH act as what we call G-protein biased partial agonists. Okay, I know that's a dense term, but it's absolutely critical. See, when classical opioids hit the receptor, they engage 2 pathways. Kratom alkaloids, however, primarily turn on the G-protein signaling pathway, which is the one that carries much of the pain relief. But crucially, they recruit very little of a protein called beta-arrestin. So why does that matter? Well, classical opioids like morphine or fentanyl are full agonists. They recruit really high levels of beta-arrestin, which has long been associated with respiratory depression. And as you know, that's the main cause of fatal overdoses. Mitragynine's G-protein bias implies a much lower risk of respiratory depression right there at the receptor level. But we have to remember this safety ceiling is theoretical. It can absolutely break if kratom is mixed with other respiratory depressants like benzodiazepines or alcohol. And you know, kratom isn't just an opioid. It's essentially a multi-target chord of pharmacology. Mitragynine binds to alpha-2 adrenergic receptors, which, by the way, is the exact same mechanism used by medications designed to blunt opioid withdrawal. It also touches the serotonergic, dopaminergic, and adenosine systems. This complex cocktail perfectly explains those low-dose stimulant, mood, and reward effects we talked about earlier. Section 4. Real-world use and harms. Data from the Grunmann's surveys and toxicology reports. So, grounding all this heavy neuroscience for a second, let's look at why millions of Americans are actually buying this complex plant from local gas stations and vape shops. According to a massive survey of roughly 8,000 users, people overwhelmingly self-report taking kratom as a medicine. They're using it to treat pain, as well as emotional or mental health conditions. And right behind those reasons, users are taking it for energy or as a harm reduction tool to self-manage withdrawals from prescription or illicit opioids. But an evidence-for-it account has to impartially name the harms, right? This plant is definitely not benign. Documented risks include hepatotoxicity, that's acute liver injury, though it usually resolves after stopping use. Regular use also definitely causes physical dependence, leading to a real, albeit usually milder, morphine-like withdrawal syndrome. Crucially, mitragynine inhibits the CYP2D6 liver enzyme. That creates some seriously dangerous drug interactions with many common medications, like antidepressants. Plus, dealing with an unregulated supply chain has led to major product contamination issues in the past, like a massive salmonella outbreak back in 2017. When it comes to fatalities, the toxicology data is actually very clear. Deaths associated with kratom certainly exist, but post-mortem studies consistently show they overwhelmingly involve polydrug combinations. We're talking about mixing kratom with other opioids, benzos, stimulants, or alcohol. Pure single-substance kratom deaths are comparatively quite rare in the literature, though we should note the risk plausibly rises when you introduce concentrated extracts into the mix. Section 5. The 2026 Regulatory Split. The law catches up with the science. Zooming all the way out to the macro level, federal regulators are actually using this exact neuroscience to completely fracture the market. Check this out. Back in 2016, the DEA withdrew its intent to ban all kratom leaf after facing massive public pushback. But as companies started bypassing the leaf's built-in biological ceiling by selling highly concentrated, semi-synthetic 7-OH products, the regulatory strategy shifted. Fast forward to July 2025, and the FDA formally recommended placing concentrated 7-OH into Schedule 1. And in July 2026, the DEA announced its intent to temporarily schedule 7-OH, while, and this is key, preserving access to the natural kratom leaf. This perfectly summarizes the final dichotomy we're seeing. On one side, we have the natural kratom leaf. It has only trace amounts of 7-OH, a built-in metabolic ceiling, and is increasingly regulated at the state level by Kratom Consumer Protection Acts. On the entirely other side, we have concentrated 7-OH extracts. These are completely stripped of their natural safety ceiling, behave a whole lot like potent conventional opioids, and are now firmly targeted by the DEA. As our source material from the OOTW Journal states, and I quote, "The regulatory line being drawn between leaf and 7-OH is, for once, a distinction the science broadly supports." Basically, regulators have essentially matched their legal crosshairs directly to the pharmacological reality, and that's pretty rare to see. Which leaves us with this final, truly fascinating thought. Right now, there is an NIH-supported trial testing purified mitragynine as a potential treatment for opioid use disorder. So as we look ahead, will this unique, biased receptor pharmacology lead to a revolutionary, safer class of painkillers? Or are we simply looking at a new frontier of concentrated, synthetic risks? It's a fascinating divide for sure, and one you should definitely keep following as the science continues to unfold. Thanks for joining me on this explainer, and keep questioning the science.